Okay, so we're going to look at difference quotient today. And difference quotient is nothing really but the average rate of change, except we write it a little different. So we know that average rate of change of a function is given by fb minus fa over b minus a. Okay? Now what if I said, well, your a was equal to x and b was x plus some amount h? Okay? How would that change? Well, that would change by, I would have my average rate of change now right? That would be f of b, which is f of x plus h, minus f of a, which is just f of x, over b minus a, and that would be x plus h minus x. And so if you look here in the denominator, if I take the parentheses out, it's going to be x plus h minus x, so the x's will cancel out, and this is f of x plus h minus f of x over h, right? So this is what we call the difference quotient, but it is exactly the same thing as your average rate of change. So the difference quotient is given by f of x plus h minus fx over h, and obviously we don't want h to be equal to 0, otherwise the denominator becomes 0. Okay, so let's look at this example here. We want to evaluate the difference quotient for the function 2x squared plus 2x plus 3. So in a sense, like I said, we want to find the average rate of change on the interval x comma x plus h, right? So we know that the difference quotient is given by f of x plus h minus f of x over h. So the two things that we need to find out, and I'm going to list them out here, is we need to figure out what is f of x plus h and what is f of x. Well, f of x is given to us, so that's not a problem. F of x is simply 2x squared plus 2x plus 3. So what is f of x plus h? So the way we do f of x plus h is I look at f of x, and wherever I see x, I replace that by f of x plus h. One thing that might help you a lot is, before we start writing f of x plus h, right, I'm going to rewrite this f of x as 2, and I'm going to put all my x's in parentheses. Okay, so now when I write f of x plus h, what I do is every time I see a parentheses, I'm going to go ahead and put an x plus h in there, right? So this is going to be 2. This x gets replaced by x plus h squared. This gets replaced by x plus h plus 3. Okay, let's go ahead and simplify that. So that'll become 2 times, if you go ahead and simplify x plus h squared, you get x squared plus 2xh plus h squared. Distribute the 2 inside, I get plus 2x plus 2h plus 3. Okay, and so finally f of x plus h is going to be 2x squared plus 4xh plus 2h squared plus 2x plus 2h plus 3. Okay, so we have all the information here. Let's go ahead and substitute everything in there. So f of x plus h is this quantity here. So this difference quotient is going to be 2x squared plus 4xh plus 2h squared plus 2x plus 2h plus 3 minus f of x, which is 2x squared plus 2x plus 3, and all of this divided by h. Okay, so now let's see. 2x squared, I'm going to subtract a 2x squared, so that's going to cancel out. I have 2x minus 2x, so that's going to cancel out. And 3 minus 3, that's going to cancel out. So the entire fx term here got cancelled out. So what we are left with is 4xh plus 2h squared plus 2h over h. Now remember, it also says simplify, right? We can simplify this further because if I look at the numerator, each and every term has an h, so I can factor out an h, and so I get h times 4x plus 2h plus 2 divided by h, so the 2h's cancel off, and so my difference quotient is 4x plus 2h plus 2.